That was the first way of looking at this. There is a second way also of looking at the very same problem, the second approach. Now, this can be the simplicity of solving this problem, but there's another way. It is always convenient, always advisable to use more than one way of solving the very same problem if there is a possibility of doing so. Now, I'm going to show you another way. Instead of multiplying both numerator and denominator by the conjugate of the denominator, we can do the following. In order to find the modulus of this, I'm going to say the modulus equals the modulus of minus 9 plus 3i all over 1 minus 2i. Now, the second approach of looking into this. And now in the second approach, what is it that I'm going to do? I'm going to treat this as working with the numerator and the denominator at the same time. So I'm going to take, because I'm looking for the argument, I'm going to take the numerator and say minus 9 squared plus into 3 squared. Divide and do the very same thing on the denominator, 1 squared plus into negative 2 squared. And I'll find 81 plus 9, I'll find 1 plus 4. And what is 81 plus 9? 81 plus 9, that will give you 90. So you will have 90 divided by root 5. And once you have that 90 divided by your root of 5, and then what is it that we can do from there? I can simplify this. I can say, okay, two factors, when you multiply them, you get 90. One of them should be a perfect square. So let me just say root 90. That would give you 3 root 10. So this is 3 root 10 divided by root 5. That's exactly what you will get. And then once you have that, you can simplify this. You can say 3 root, I know that root 10, it's 5 times 2 all over root 5. Let me just check if everything is fine. Very good. And I can simplify this. I can simplify 3, this as 3 root 5, root 2 divided by root 5. And root 5 into root 5 goes once, giving you an answer of 3 root 2. Did we not find the argument previously as a 3 root 2? That's exactly what we did. That's exactly what we found. In the previous tutorial, we found exactly the same thing. And now the question is, how do we find the argument now? How do we find the argument? The argument W of what? How do we find the argument? Now, the argument of what we have there, let's say minus 9 plus 3i all over 1 minus 2i. How do we find the argument, the angle there? Now, the same procedural method can be applied. Remember, we're going to look at the numerator and the denominator at the same time. So I will find the argument of minus 9 plus 3i looking at the numerator, and I will subtract from the argument of the denominator. Very, very important that we understand that. Very, very important that we understand that. And I know that this will be arc 10 of, this is the real root and this is the imaginary root. And remember, 10, it's opposite the imaginary root over the adjacent, the real root. Please be very, very careful. This is positive and this is negative. Minus arc 10 of the imaginary root, that will be minus 2, divided by the real root, that would be 1. And let's see the values that we can produce with this. So I'll just go to my calculator here and say, okay, arctan or tan the inverse of 3 divided by -9. And you will find a negative value there. And I know that whenever an angle is negative, I must go and add 180 to that. So I'm just going to come here and say plus 180. And I will find 161.5650 512, and I'm going to minus arctan of -2, and I'll find negative, so I'm going to add 180 to that, and I'll find 116, comma 512, and I'm going to subtract those two, so I'm just going to say 161.5650 minus the answer that I got, minus 116.5650 and I will get 45 or pi over 4. That's exactly what I will find, because in degree measure it's 45, in radian measure is pi over 4. So this is 2 ways in which you can try and look into this. You don't have to multiply both numerator and the denominator by the conjugate of 1 minus 2i. This can be the procedural method that you can also follow. And thank you for watching. I will see you in the next tutorial.